Okay guys, here we go. Today what I'm going to do is I'm going to talk to you about the functional unit of the kidney. And the functional unit of the kidney is the nephron. But before I begin, what I want to do is just give you a basic overview of the urinary system. As everyone knows, you got two kidneys, little bean-shaped organs. And one of their big functions is to filter out the plasma of the blood. So remember, only the plasma of the blood is filtered. So any of those really big formed elements in the blood, like red blood cells, white blood cells, and that big freaking protein, albumin, should never be found in your urine. If you do find it, then there's something going on with you, something ain't right. These things are too big, so they're basically caught and remain in the blood in the nephron. I'll get into more detail about that in a minute. Excuse me. So, you have the renal artery, and remember, it's the arterial blood that's actually filtered by the kidney. So the arterial blood enters the kidney through the renal artery. That blood then gets filtered, the plasma gets filtered and forms urine. The urine then leaves the kidney through these two hollow muscular tubes called ureters. And these ureters use peristaltic wave, the rhythmic contraction and relaxation of the muscular walls of the ureter, to push that urine into the urinary bladder. Then the urinary bladder fills up, stimulates baroreceptors, and initiates the micturition reflex, and you pee. So let's take a closer look at the inside of the kidney. Here's a cross-section of the kidney. So as you can see, as the renal artery right here enters the kidney, the arteries begin to branch off and become smaller and smaller until they terminate at the afferent arteriole. And each kidney has anywhere from 1 to 1.5 million of these functional units, these nephrons. And in the nephron, this is where the plasma of the blood is filtered. So let's take a little closer look at the nephron. So the nephron is basically made up of the glomerulus, which literally means ball of capillaries. And then the glomerulus will filter the plasma, and it will end up in these collecting tubules. So all these little different tubules collectively are called the collecting tubules. So this is where you form the urine. Now, as you're traveling through the yellow brick road, the stuff that was filtered, some of the stuff that got filtered, the body needs. So it's analogous to cleaning a closet. You clean a closet by taking everything out of the closet, and then after you've cleaned it, you decide what you want to put back into the closet. So the nephron, and specifically the glomerulus, filter all of the plasma, and then as it travels through the yellow brick road, it will selectively bring stuff back into the blood. So let's look at a couple of terms that you guys should be familiar with. So here, the process of forming urine. But before you do that, let's look at some terms, right? Number one, filtrate. Filtrate is defined as the plasma that was filtered by the glomerulus and then enters the collecting tubules, right? So that's the stuff that enters the collecting tubules that got filtered by the glomerulus. So you've taken everything out of the closet. That's the filtrate. Now, reabsorption is putting back the stuff into the closet that you still want. So as that filtrate travels through the yellow brick road, the kidney decides what it's going to bring back into the blood. So the reason it's called reabsorption is the stuff got absorbed from your GI tract into the blood. Then that blood, that arterial blood, will go to the nephron, and the plasma of the blood will get filtered out of the blood, and the stuff that the body wants, the nephron will reabsorb back into the blood. That's why it's called reabsorption. And then finally, some stuff can't be filtered by the glomerulus. So it has to be actively pushed from the blood into the collecting tubules, and that's called secretion. So those three processes that occur in the nephron, and after you've done those three processes, whatever's left over is your urine. So to make urine, you got to filter the plasma by the glomerulus. The plasma then is going to enter that yellow brick road, the collecting tubules, and then as the filtrate moves through the glomerulus, the stuff that the body needs will get reabsorbed back into the blood. And then number 4, which I don't have here, but would be some things in the plasma cannot be effectively filtered by the glomerulus, so it has to be actively secreted. So that's the process. So let's go into a little more detail. So first of all, what you got here is you have the afferent arteriole, and the afferent arteriole takes that blood, that arterial blood, into this ball of capillaries called the glomerulus. And the glomerulus is actually a little more porous than your normal capillaries, so it allows the plasma to be filtered effectively. What's not filtered by the glomerulus then leaves the glomerulus through the efferent arteriole. And then the efferent arteriole forms a network of capillaries around the yellow brick road, the collecting tubules, and it is there that as this filtrate travels through the yellow brick road, that stuff will be reabsorbed back into the blood. And each portion of the collecting tubules has its own unique responsibility. And I'm very general when I'm explaining this stuff. So if we look here, take a little close-up view of what the glomerulus actually looks like in a simplified view, I'll show you. So here you have a big kind of blown up view of the glomerulus. And as you can see, it's this ball of capillaries. And then the arterial blood is going to come in under pressure, very important, and it's going to filter out the plasma. Now, the big stuff that's in the blood that should never be found in urine, red blood cells, white blood cells, and albumin, is because of, by virtue of its size, too big to get through the glomerulus. Now, in some people, as their kidneys are failing, this glomerulus kind of falls apart. So you'll find this stuff in the blood, and that's an indicator that their kidneys are failing. It's really a late indicator, but we'll talk about that later. Anyways, then that blood that wasn't filtered by the glomerulus then leaves the glomerulus through the efferent arteriole. And then the efferent arteriole then forms this network of capillaries called the paratubular capillaries, right here, around the glomerulus, or I'm sorry, around the collecting tubules, and that's where the stuff gets reabsorbed back into the blood. So this is what I want to explain. So watch. Arterial blood comes to the glomerulus under pressure, and the higher your blood pressure, the more plasma is filtered. So anything that causes an increase in blood pressure, systolic blood pressure, is going to force the nephron to make more urine. So that blood's going to come into the glomerulus. Then the plasma of the blood gets filtered. Remember, all the plasma gets filtered. And this little cup surrounding the ball of capillaries is called Bowman's capsule, or the glomerular capsule. So that's where the filtrate, the stuff that was filtered by the glomerulus, first enters. Then it travels into the first section of the collecting tubules, and that first section is called the proximal convoluted tubules. Proximal because it's closest to the point of the origination of the nephron, and it's convoluted, twisted, so that's why it's called the proximal convoluted tubules. And this is important. 70% of the stuff that got filtered by the glomerulus will then get actively reabsorbed back into the blood. So it makes sense, right? You clean your closet and you pull out some skis. If you know the skis are going to go back into the closet, you're not going to take them into the garage and then have to go out to the garage and bring them back in. You're going to leave them right next to the closet so you can put them back in quickly. So that's what happens. So when you filter the plasma, the proximal convoluted tubules is where you reabsorb most of the stuff the body needs back into the blood. And approximately 70% of the stuff and water gets absorbed back into the blood in the proximal convoluted tubules. Then as you can see, the proximal convoluted tubules kind of end. Then these tubules kind of dip down into the medulla of the kidney, the inner portion of the kidney. This little thin loop here is called the loop Don Henle. Lupa Henle, just so you know. Anyways, and you have this descending limb right here. And in the descending limb of the Lupa Don Henle, the only thing that can get reabsorbed back into the blood is water. So this is where water gets reabsorbed, and it gets reabsorbed by osmosis. Then the loop starts its ascending route. And in the ascending limb, the only thing that can get reabsorbed is stuff, solute. So that solute, electrolytes, get reabsorbed back into the blood. Then you can see that this kind of thin portion gets kind of ballooned out. This is called the thickened portion of the ascending limb. And in the thickened portion of the ascending limb, this is where electrolytes are actively pumped in. So you got pumps in there that will take the electrolytes, and using ATP will pump those electrolytes back into the blood. Just real quick, a little clinical thing here. It is this portion in the loop where sodium, potassium, and chloride get reabsorbed back into the blood. And when you reabsorb these things back into the blood, water will follow it. But these guys are actively pumped back into the blood. And they're all three reabsorbed at the same time. So if one is not reabsorbed, none of them are reabsorbed. So there's a drug out there called Lasix that prevents chloride from being reabsorbed back into the blood. So if you don't reabsorb chloride, you don't reabsorb potassium, and you don't reabsorb sodium. So the more stuff that remains in the collecting tubules, the more urine you produce, the more diuresis you produce. So that drug that prevents chloride from being reabsorbed, therefore potassium and sodium from being reabsorbed back in the blood, is called Lasix. So Lasix functions on the thickened portion of the ascending limb of the Lupa Don Henle. That's how it works. Now, then you get the tubes kind of thicken out, and they become twisted again. And because they're farther from the point of origin of the glomerulus, these are called the distal convoluted tubules. And the distal convoluted tubules are influenced by hormones. So there are really three big hormones that affect the distal convoluted tubules and determine whether you're going to make a dilute urine or whether you're going to make a concentrated urine. So in the distal convoluted tubules, the three hormones are ADH, antidiuretic hormone, ANP, atrial natriuretic peptide, and then our buddy aldosterone from the renin-angiotensin-aldosterone mechanism. And I'm not going to go into how these work. You can learn that in the advanced class. But these hormones then will either make less urine or more urine, depending on the needs of the body. And then finally, all the collecting tubules, or the distal convoluted tubules, connect to the collecting ducts. And in the absence of hormones, water is impermeable into the collecting ducts. And the collecting ducts then dump their contents, which is now urine, into the minor calyx, which goes into the major calyx, renal pelvis, ureter, bladder, out into the world. So that's really the structure and function of the glomerulus. Just a couple of things very quickly. Glucose is small in comparison to red blood cells, white blood cells, and albumin. So when the plasma is filtered, you have glucose in the plasma, as you know. But in the collecting tubules, you can reabsorb glucose, all of it, back into the blood if your blood sugar never goes above 180 milligrams per deciliter. And if you eat a bunch of sugar, if you're not diabetic, your blood sugar should never go above that. So you should never find glucose in your urine. However, if you are diabetic and your blood sugar is, say, 300, then you're not going to be able to reabsorb all that glucose back into the blood, and that glucose will leave in your urine. So a quick and dirty test to determine if somebody's diabetic is you have them pee in a cup, you dip it for urine. If it's positive, they're diabetic. So that is the nephron.